Okay, so for this video, we're going to be determining the length of an arc. Now, just to clarify, when we have an arc, that means that we have a circle, and we have a central angle in that circle, which means that it goes to the center of the circle, and that angle does something we call subtending, which means it cuts off a piece of the circle, and that piece of the circle is called the arc. And what we're going to be finding is S, which is the length of that arc. So in order to find S, the length of the arc, we're going to use radius times theta. Now the problem here is that theta has to be in radians. So let's make that very clear. Theta must be in radians. So if we're working with a problem, such as example 4, and we decide we want to find the length of the arc of a circle with a radius of 4 meters, subtended, meaning cut off, by a central angle of 0.5 radians, well, that's in the correct format. So we have no problem. We write our formula, S equals R times theta. We plug in what we know. We know that R is 4 and theta is 0.5 radians. We multiply those two together and we're going to get 2 meters, and that's the length of the sector, that's the length of the arc of the sector, that's the length of the arc of the circle, that is 4 meters in radius with half a meter central angle, and that's going to be right here at our theta, and that's 2 meters. 4 times 0.5 gives us 2 meters. Now this next example problem says same thing, find the length of the arc of a circle with a radius of 7 meters. Subtended, of course, means cut off by a central angle of 40 degrees. Now the problem with this one is 40 degrees is not in the correct unit of measure. So before we can even get started, we have to come over here on the side and we need to convert 40 degrees to radians. So if I take 40 degrees, I'm going from degrees to radians. Remember that I multiply by pi radians over 180 degrees. And the degrees cancel, and we can simplify. 20 goes into 42 times, 20 goes into 189 times, and that's going to equal 2 pi over 9 radians. That's my theta. Well, now my theta is in the correct units, so I'm going to come along and do S equals R times theta. So that's 7 times 2 pi over 9, which is 14 pi over 9 radians. Now we can put that in our calculator, 14 pi over 9, and find out that is approximately 4.89 meters in length. Okay? So once again, the formula for an arc length is S times S is equal to radius times theta, but theta must be in radians. To find the area of a sector of a circle, let's draw our circle with a radius of R. Here's a radius of R, and there's a sector that's subtended by the central angle. There is the sector. This is the arc that's subtended by the angle, but this is the sector. And to find the area of that sector, we're going to use the following formula, and that's 1/2 times radius squared times theta. It's not a very difficult formula. It's just 1/2 times the radius squared times the theta, but once again, theta is in radians, or this formula will not work. You must put theta into radians, or the formula will not work. So let's take a look at example 5. Find the area of a sector of a circle with a radius of 10 meters, subtended, which means it's cut out, by the central angle of 3 radians. That's in radians. That's what we want. So we'll just write our formula. Area equals 1/2 R squared theta. So that's 1/2 times 10 squared times 3 radians. We multiply that together. That equals 150 square meters, because that's an area unit of measure, so it's 150 meters squared. Remember that area units of measure are squared. Let's look at example 5b. The area of a sector of a circle with a radius of 8 meters subtended by a central angle of 45 degrees. That is not in radians. Now, I'm going to come over to the side and we're going to convert 45 degrees to radians, but I want you to think for a second. Think about your unit circle. What was the radian measure for 45 degrees? Kind of have that number in your head because that's how we'll know if we are converting correctly. So I'm going to take 45 degrees, multiply that by pi over 180 degrees. Pi over 180 degrees, this is our theta. We're going to get simplified, which means that 45 degrees, 45 goes into itself once, 45 goes into 180 4 times, and that's going to give us pi over 4. Now, do you think about the unit circle? Where was pi over 4? It was at 45 degrees. So we know that's now right. That's our theta in radians. So we can do our formula. Area equals 1/2 times radius squared times theta. That's going to be 1/2 times 8 squared times pi over 4. Now, this is a little bit of complex multiplication. This is equal to 1/2 times 64 over 1 times pi over 4. We're going to do some simplifying. 2 times 4, the 2 and the 4 can cancel going into 64 8 times. So we have 8 pi is meters squared is our actual area. That's the actual answer. That is the exact answer. So to get it approximated, if they wanted it in decimal form, we plug this into our calculator and we will get 25.13 meters squared. Okay? Don't forget your unit of measure. Don't forget that your central angle must be in radians. Once you do that, plug and chug into the problem and good luck.